All right. So we started off with trying to understand the 6 basic trig ratios: sine, opposite over hypotenuse, etc., 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 right? All through. And we also found that we can use our sine button, cosine button, and tangent button. And what we found is that we input the angle, hit that correct button, and it'll tell us that ratio in decimal form. So, for example, when we punch in sine of 10 degrees, we punch in 10 degrees, hit the sine button, and it tells us the opposite over the hypotenuse for a 10-degree angle involving a right triangle. All right, so now we need to use the inverse buttons, and it's the other way around. Now we're going to input the ratio, and we're going to be able to find the angle measure. So we're finding the angle measure. Finding the angle measure. And it's just your -1 buttons. Sine to -1 button, cosine to -1 button, tangent to -1 buttons. So again, you're inputting the ratio a lot of times in decimal form. Sometimes you're inputting it as the fraction, as the actual ratio. It doesn't matter. You know, does it matter if you input 2/3 or input 0.666? It doesn't matter. Does it matter if you put in 2/5 or 0.4? It doesn't matter. They're the same thing, just two different forms of the same thing. You're inputting the ratio, and you're going to then, therefore, be able to find the angle. But you got to keep that straight. The -1 buttons allow you to find the angle. The -1 buttons allow you to find the angle. So what if you had something like sine B equals 3/5 and you had to solve for B? All right, if you want to be a technician, and if you want to think about it this way, basically, and this isn't really true, but if you wanted to math-wise say, what if I multiply the left by 1 over the sine and the right by 1 over the sine? And that would kind of get rid of the signs. It's not really what's going on, but you can think of it that way if you want. Okay, how about negative exponents? If I have a positive exponent in the denominator, what is it in the numerator? Negative, right? Because it changes as you go across. So instead of writing sine 1 over sine, could I write sine to the -1? Indeed, I could. And that's really where the notation comes from. Although, again, that's not exactly mathematically the case. All right, so what do you really do when you're solving these? So if you got sine B equals 3/5, then just make it sine to the -1 of whatever that ratio is. That's all it is. And really what I do is I write the geometric designation measure angle B, right? Because that's what you're looking for. And here's what happens with students. You get confused as to what I'm looking for. And you can't get confused there. You have to keep straight whether you're looking for the angle because you know the ratio, or whether you're looking for the ratio because you know the angle. You can't get them confused. So if you have a trig function and then after it you have some kind of letter, A, in this case it's a B, you might have a symbol, a theta. We like to use Greek letters, an alpha, etc. Well, now you're looking for the angle because what comes after the function is the angle. So you got to keep that straight. So you're going to use a -1 button to find the angle. You're going to use a regular button to find the ratio. And so that's the idea. So the measure of angle B equals sine to the -1 of 3/5, right? And that's what you're punching in to your calculator. So again, your calculator syntax matters. How does your calculator want you to punch this thing in? It depends on your calculator. Some you can do 3/5. Then you can do your second button, hit the sine to the -1 and hit enter. Others of you got to do sine to the -1 first, right? So you got to do second sine. So everybody punch it in. Make sure you can get your calculator to give you the measure of angle B. And the other thing is you want to be in degrees right now because we're going to learn later on in the chapter about radians. That's another way of saying angles, just like meters and inches. So you want to make sure your calculator is in degrees. Otherwise, you're not going to like your answer. So what'd you get? Just say it if you got it. All right, and usually I go to 1 degree, or to 1 decimal place, so 36.9 degrees. So again, you got to make sure you know how to punch your calculator to where your screen says 36.9. on the round off. Anybody need help with your calculator? Anybody? We're good. 36.9. You punched it in. You like it. Okay. I hope so. I hope so. I hope so. Okay. All right. So again, that's the aspect. I'm going to leave that note. I already mentioned it, so we don't need to fool with it. Okay. So now you get to a problem like we got here in B. Tangent x equals 3.5249. Solve for x. You say like, wow, this is an easy problem. Piece of cake. No sweat. This is the way I would write it up, though. The next thing I would do is I would say the measure of angle x equals tangent to negative 1 of that 3.5249. And that's all the work I need, but show that work. Why do I need to show that work? I know all I'm doing is hitting the negative 1 button. Because your brain remembers you writing it. Because you're building pathways in your brain by even writing it. Because you got to remember. And look, I don't need you to remember for 2 weeks for the test. I need you to remember a year from now for the ACT or SAT, right, Dolores?
For these ones, do you not round it to the 4 decimal places?
No, because we're no longer doing a ratio, we're doing an angle, right? And so that's the difference. Just like in logarithms, when we were finding the exponent, we went to 4 decimal places, but when we weren't finding the exponent, we didn't necessarily do that. So the degrees, usually angles, I round off to 1 decimal place. Now, what if they ask you to put it in degrees, minutes, seconds? Well, get the angle first and then convert it with your button, right? So find out the angle, go through the trig function, find the angle, and then convert. All right, so what did we get here for measure of angle x? 74.2 degrees, right? Pretty simplistic, not a whole lot involved there, piece of cake, no sweat. So you look at C, same thing. So go ahead and do C. You do it at your seat, I'll do it up here at the same time, and I'll be in Scotland before you. Or maybe not, because you might not write the work. But I already have the answer, so. So you're looking good at 71.4 degrees? Yes? All right. Let me know, because, hey, it's easy to punch a wrong button. You got to be careful with these. It's easy to input. You think you're inputting a 5 and you're inputting a 6, et cetera, et cetera. Okay, so D is really the same kind of problem with a little bit of a twist. And it wants you to find A. And you say, well, what is A? A is the angle. Only it doesn't tell you which trig function to use. You have to figure it out. Well, you figure out which trig function to use based upon what they gave you. So I always circle the angle I'm solving for. And I look at what I have. They gave me the 7, which is the what? Opposite. And they gave me the square root of 140, which is the... And therefore I choose the sine. See, this is the thinking you have to go through. Because they gave me the opposite and they gave me the hypotenuse, I choose to use the sine of angle A. And I know it's the opposite 7 over the hypotenuse square root of 140. So now I made the problem look like C, right? I did it myself because I knew the sine is the opposite over the hypotenuse. So finish it off, and I'll finish it off. All right, and 36.3, you like? I like. So again, you're just hitting your sine to the negative 1 button of 7 divided by the square root of 140. Hold on a second before you turn your notes. So by the way, some people like, well, shouldn't we simplify the square root of 140? Who cares? We're punching it into our calculator. Right? All this a round off. So, everything's a means to an end. Do I really care to simplify? You have a radical in the denominator. Shame on you. It's not our final answer. Yeah, we can't leave a radical in the denominator on our final answer, but it's not our final answer. I'm not going to do all that other stuff to get rid of the radical. I don't need to. The calculator is just going to calculate. All right, one last thing before you turn the page. All right, I just want you guys to take note of something that you think is not important. Come on, where are you? That's what I want. You don't think it's that big of a deal, but I want to see if indeed you're thinking the way I'm thinking. So let me ask you, how many of you, your notes look like that? Let me see your hands. Okay. Do you have it A circled? Do you have the lines going? I guarantee you not everybody does. Yes, see, those are the little key things that you don't pick up on that you need to pick up on, because that's telling us what to do. So that's what your notes should look like, because that's what's telling us what to do. That's why we chose the sign. All right, it's the little things, little things, little things. All right, so then you get into realistic type problems, quote unquote, quote unquote. Find the height of the window. We really need to know this. All right, don't ask me why, but we really need to know how high that window is. All right, so we got to find the height of the window. Got to have the height of the window. So hopefully you would agree, I'll call it X. That's the height of the window. And the bottom of the window. Because maybe you want to jump out. You're going to sneak out. Gee, will I kill myself if I jump out my window? Most people would look and say, yes, I'd be an idiot, but all right, so whatever. Maybe Romeo's going to come and he needs to know how big of a ladder to come to get you, ladies, from your window. So I don't know. So it's the same kind of problem, at least similar. And this one, they gave me the angle. I'm looking for the opposite. They gave me the adjacent. Therefore, I choose the opposite and adjacent. I choose the tangent. That's the way you do all these problems. See, that's why you have to have in your mind, and you can't be going through SOHCAHTOA, 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 all right? You got to know the sine is the opposite over the hypotenuse. You got to know the cosine is the adjacent over the hypotenuse, and you got to know that the tangent is the opposite over the adjacent. You got to know that stuff. It's got to be in your brain, in the forefront of your brain. You can't be rotating through SOHCAHTOA. All right. I guess if that's all you got, do it, but that's not the best. All right. So we're choosing the tangent. What comes after the word tangent? What comes after the trig designation? The angle, right? So the 47 comes next, because we're doing the tangent of 47 degrees. And now we're going to write the ratio. The opposite is the x, and the hypotenuse is the 30 feet. Now again, why do we do this? Because this is the opposite and this is the hypotenuse. Some of you don't need to write that. Some of you need to write that. Again, some of you need to write here angle, because you don't quite understand where stuff goes. Adjacent, thank you. No Kool-Aid for you guys. Opposite over adjacent, right, is tangent. What do you have? A little equation. And look, they're nice because they're fraction equations. They're kind of proportional. Things on the bottom go to the top across the equal sign. Just put the 30 up there. That's it. You're ready to solve this for x. With one caution. Just be careful. You cannot multiply the 30 times the 47 and then take the tangent. That's not true. This tangent 47 is one entity in and of itself, and you can't be distributing. Yeah, you'll multiply whatever that is times 30, but those have to stay separate. So just make sure you can't do 30 times 47 and then hit tangent, nor can you do tangent times 30 times 47. But you should be fine if you do 30 times the tangent of 47. All right, punch it out. Make sure that you're figuring out how to punch out your calculator. And so on this thing, 32.2 feet should give a designation as to units. The 30 was in feet. Does my answer make sense? Yeah, that makes sense. That makes sense, I guess. It's a tall window. It's one of those big mansions like around here. So you're not jumping out that, I hope. Okay. Third story. Usually a story's about 10 feet, so that is kind of higher. They must have nice vaulted ceilings in this house, so who knows. All right, whatever. Whatever. Everybody okay with their calculator? Everybody punching it right? You're able to get the answer? Okay. All right, B. How deep is the shock? Notice at the same time I'm mentioning to you guys, remember from geometry, angle of depression from the horizon down is depression. From the horizon up is the angle of elevation, right? So just terminology. All right, so this time we're looking for the angle, right? No, we got the angle. We're looking for the depth. So, look, I hope you can understand that this is the depth right there. All right, how deep is something in the water? It's from the surface down would be the depth. And again, you're going to look and see from my angle, what do I know? They told me the opposite. Or I'm looking for the opposite. They told me the hypotenuse. Therefore, I choose the sine. And the sine of what? 37 degrees equals what? The opposite x over what? The hypotenuse, 45 feet. And you're making your equation out of the trig ratio. But in this case, we're looking for an answer. So the 45 feet goes across the equal sign to the top, and we're punching out 45 times the sine of 37 degrees. Making sure you ask yourself when you're done, does my answer make sense? Look, if you get the shark is 0.72 feet in the water, you got to say to yourself, I think I did something wrong. All right? If the shark is 8,000 feet in the water, I think I did something wrong. Because he'd be in the Marianas Trench or something. So you got to think, and hopefully the shark is 27.1 feet deep. Is that okay with everybody? 27.1 feet. You just, at this point, you're punching buttons. That's all the work I need to see on a problem like that, but I should see that. By the way, if they give you a word problem, I should see a picture that you made of the triangle. You're like, here's somebody, this is a person's face. How in the world are you going to do the problem without a triangle? How are you going to do it without a triangle? Like, why did they even have to say that? Yet, some of you are, you're torturing me. It's like waterboarding. I have to write and have to draw the triangle. All right, so here's a guy flying his kite. Goofy, I know. Find the height of the kite. All right, we're right now off the triangle. We're looking for n, right? Let me go a little higher for you. Looking for n. All right, you guys do this one. I'll do it up here while you're doing it at your seat, and we'll see if we get the same answer. All right. If you need help, look up. If you don't need help, try not to look up. How would you do the problem? What's the height of the kite? So you chose your ratio. Hopefully you chose a tangent. Looking for the opposite. And hopefully you added in the 5.5 feet when you're done, because from his eyes up was the 115.4 feet. This is not to scale. Hopefully you figured that out. Does it make sense? You got to add the 5.5 feet from his eyes down, right? If you're really going to get the altitude of the kite. Questions on that? So again, same procedure, right? You're going to figure out where you're at and you're going to go from there. Okay. 2 more situations to go. So what if they just give you a very generic plane triangle and they say solve the triangle? If they say solve the triangle, they want all sides and all angles. And there's 2 different ways these problems will come. This is the first example gives you the first possibility, and the second example gives you kind of the second possibility. So in this first example, you have 2 sides. You don't know either acute angle, but you do know 2 sides. So from here, you got a couple different routes you can go. If you were going to get the third side, how would you get the third side? Pythagorean theorem. So go ahead and let's figure out the third side. Are you at the point where you know it's going to be the square root of what squared? Say it if you know it. 12 squared and then plus or minus. Minus, right? Whenever you have the hypotenuse, it's the hypotenuse squared minus the other side squared. So that's what? 144 minus 16. And what in the world is that? 128. And look, just leave it as the square root of 128. If it was asking us for, oh, you know what? It wants the side length, doesn't it? So on this one, we're going to have to simplify because it wants all 3 sides and it wants all 3 angles. And what's better, a round off or an exact answer? An exact answer. So this one, yeah, we got to simplify actually. 28, 2 times 64. 128, right? 2 times 64. 64, 2 times 32. We already got a 2 out. And let's do 32 as 2 times 16. So you get a 2 out for the 2 times 2, and you get a 4 out for the square root of 16. Do you agree? Your brain thinking, right? Taking square root of 4, square root of 16, that's an 8, right? 2 times 4 is 8. So 8 times square root of 2. And that's the first answer, right? That's side xy. Because it wanted all sides. If we were just figuring out angles and stuff, it wouldn't matter. We just leave it square root of 128. But they want the value of the side, so we're going to give them an exact answer. Okay, so how do we start getting the angles, though? By the way, let's do the easy angle first. What's the measure of angle x? All right. That was easy. Take care of that one. So we got 2 things left. Measure of angle z, measure of angle y. Oh my. What am I going to do here? All right, which one you guys want to do first, y or z? Z. All right, I heard z. Let's do z. So let's first off find z. I'm going to write find z. How would you start? I would start by circling angle z. Now I know all 3 sides of the triangle, but what 2 do I know are definitely correct? 4 and 12, all right? I'm not going to use my answer because what if I made a mistake? Am I guaranteed to get z wrong if my Pythagorean theorem is wrong? Yeah, so why use it? I'm not going to. It's stupid to use it. So use what they gave you. They gave you the adjacent. They gave you the hypotenuse. Therefore, you will use the trig function of the cosine. Cosine. What comes after the cosine? Z. And what does it equal? The adjacent 4 divided by the hypotenuse 12. All right, let's see how quickly you forget. All right, find z. Go ahead and finish it off. Find z. You know, some of you are looking at it like, I'm not sure what to do. All right, this is how we started today. The measure of angle Z equals cosine to the negative 1 of 4/12. All right, you're punching it out. Remember, your negative 1 buttons gives you the angle, right? Earlier, we weren't looking for angles when we were doing the other type problems. Okay, so you punch that out, and what do you get, 19.5 degrees? Oh, I did it backwards the other way. So did you get 70.5? Okay, so 70.5 degrees is Z. Most will say at this point, you know what? If Z's wrong, I'm going to get Y wrong, but it's just way too easy to get Y if you know Z. So I'm just going for Y that way. I'm going to trust myself, and I'm going to say the measure of angle Y is 90 minus 70.5, because it's just way too easy. Right? The two equal 90. So therefore, the other one's got to be 19.5 degrees. And now we found all three angles, and we know all three sides. Okay? For some reason, I don't know why it is, but if I just gave this triangle and said find the measure of angle Z with nothing else, students freeze on that. But again, it's okay, I'm looking for Z, I know the adjacent, I know the hypotenuse, write the trig function and solve for the angle. It's the negative 1 button. Negative 1 button. Negative 1 button. All right, what else? Here's the second scenario, where notice in this case, they give you one acute angle and one side. What would you get first on this one? What would you go for first? Angle A, right? Because that's easy. And angle A is going to be simply 90 minus 21. So that's 69 degrees. And we got angle A. All right, again, just 90 minus, right? Algebra 2, I don't really necessarily need to see the 90 minus, all right? It's just 69. Okay, but we still need two sides. And you can't use the Pythagorean theorem. All right, so what do you want to go for first? Do you want to go for B to C or A to B? B to C? All right, and I'll tell you what, let's label them. A lot of times you'll label side by its opposite angle. So we'll call B to C side A, and we'll call B to A side C. That's just normal labeling. You could call them X or Z or N, whatever variable you want. So Hunter, you said B to C, right? Okay. So how are you going to find side A? So let's write up here side A, so we understand what in the world we were doing. At least that's supposed to look like side A. That's an ugly side A. Okay, so if you've caught on, what I've done every time I had to find a side or I had to find an angle, I always started out by doing what? Circling the angle. So you can use the 69 if you want, but again, I just always use the one they gave me. You could use either angle. It doesn't really matter, but I like to use what they gave me. They gave me the 21 degrees. They gave me the opposite. I am looking for the adjacent. So opposite adjacent, I'm going to use the tangent. And again, that's why you have to memorize sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You cannot be successful in trig without having that in the forefront of your brain. All right, so I'm going to use the tangent. What's the angle? 21 degrees. What does it equal? The opposite, 14, over the adjacent, which is A. All right, I chose this problem this way on purpose because most students will get this problem wrong. Even at this point, they might write tangent 21 equals 14 over A and still get it wrong. So what are they going to do wrong? Here, I'll show you what they're going to do wrong. Don't do this. This is what they're going to do wrong. Here, I'll do it in red. That's what they're going to do wrong. And they're going to divide the tangent of 21 degrees by 4. Is that what you would have done? Or 14? Is that what you were going to do? Some of you are going to do that. And why is that wrong? Because the a is in the denominator. You can't solve for the variable in the denominator. So look, honestly on this, the first thing you got to do is stick the a in the top. It's got to go from the bottom to the top. Things in the bottom go to the top across the equal sign because you're multiplying both sides by that over 1. That's all. It's just a shortcut. And by the same token then, move the tangent 21. Right? So really you end up dividing the 14 by the tangent of 21 degrees. And you just punch that into your calculator. So again, make sure you know how to punch it in and get the correct answer. Because you have to take 14 and divide it by the tangent of 21 degrees. And you got to ask yourself, does my answer make sense? Look, if side A is 0.27, you know you made a mistake, right? That's 14. This is going to be 0.27. I don't think it's that off on the scale drawing. Or if you get side A to be 138, okay, you got to say I made a mistake. But if you get side A to be 39.1, wait, is that A? Is that the other one? Let's see. What's side A? 36.5, yeah, looking at the other one. So 36.5, and there are no units, so we'll leave it unitless. Everybody okay with 36.5? So for me to finish, I'm going to use a trig function again to get C. You can use a Pythagorean theorem, but now you have decimal round-offs already. It's not the advised way to go. So again, in my mind, I'm going to stay with the 21 degrees. So the second time, here, what color is left? I used red, green, black. I guess we got to use black. So if I'm going to find side C, I'm going back to angle B. I'm going back to the opposite. And this time, I'm finding the hypotenuse. So now it's opposite hypotenuse, and I'm using the sine. So now it's sine of 21 degrees equals the opposite 14 over the hypotenuse C. And go ahead and figure that one out and get C. Stop by after class is over and see me. Okay, and did you get 39.1? 39.1. Hypotenuse is the longest side. We're feeling good about that. Again, if they would have told us feet, we would have said feet. If they would have said inches, we would have said inches, meters, whatever. That's the aspect. All right. I'm quitting here in this lesson because, again, they packed in a whole bunch of stuff on one lesson. So I'm going to stop here. We're going to work some homework over this stuff tomorrow in class, and then we'll continue on to the next section. All right, so that's it for today.